A thin uniform rod pivoted at O is rotating in the horizontal plane with constant angular speed omega as shown in the figure. At time t equals to 0, a small insect starts from O and moves with constant speed v with respect to the rod towards the other end. It reaches the end of the rod at t equals to capital T and stops. The angular speed of the system remains omega throughout. The magnitude of the torque about O as a function of time is best represented by which of the following plots? In this question, we have to find out the torque, which is given by tau is equal to dl by dt, where L is the angular momentum. Also, we know that angular momentum is given by L is equal to I omega, where I is the moment of inertia and omega is the angular velocity. It is given in the question that throughout the process omega remains constant. Now, substituting the value of angular momentum in the above equation for torque, we get tau is equal to d by dt of I omega. As omega is constant, it can be taken out of the differential term. So, tau is equal to omega into di by dt. Let us now evaluate the moment of inertia of the system. The moment of inertia for the rod about one end point is given by ml square by 3, where m is the mass of the rod and L is the length of the rod. Also, the moment of inertia of the insect is given by m dash x square, where m dash is the mass of insect and x is the distance of insect from the point O at any time t. Here, we have considered insect as a point object. So, the moment of inertia of the entire system is given by ml square by 3 plus m dash x square. Now it is given in the question that insect moves on the rod with a constant speed v with respect to rod. So the distance of insect from the point O at any time t is given by x is equal to v into t. Substituting the value of x in the above expression for I, we get moment of inertia is equal to ml square by 3 plus m dash v square t square. Now let us substitute the value of I in the expression for torque. That is, tau is equal to omega into d by dt of ml square by 3 plus m dash v square t square. As the mass of the rod and the length of the rod is constant, the differential of ml square by 3 is equal to 0. Solving this, we get tau is equal to omega into 2m dash into v square t. So, torque is directly proportional to time. Therefore, the plot of torque versus time will be a straight line passing through origin. So, the plot between torque and time will be a straight line passing through origin for time less than capital T. Now, at t is equal to capital T, the insect reaches the other end of the rod and stops. So, the velocity will be equal to 0. Therefore, torque, which is directly proportional to v square, will be equal to 0. So, for t greater than capital T, the graph will be on x-axis. which matches best with option B. Therefore, the correct answer for this question is option B.